Welcome to Mental Matrix with EJD. Today we are estimating square roots. Now, if you look at 90, you know that after 90 is 100, and 100 squared, 10 squared is what gives you 100, right? So automatically, you would also know that if you have 9 squared, that gives you 81. And then if you have 10 squared, that gives you 100, right? So it means that 90 should be something between 9 plus 10 divided by 2 squared, something close to that, right? So the square root of 90, we can say is something like 9 plus, the square root of 90, the square root of 90 can then be said to be something like 9 plus 10, okay, divided by 2, which is 9.5, okay? So it's just an approximation, right? Actually, if you punch your calculator for this, the answer is something like, the square root of 90, if you punch your calculator, is approximately 9.486. So you can see that the answer is really close. So you can see the answer is really close. All right, so that's how to estimate square roots. Okay, let's move on to the next one. The next one is square root of 28. Okay, the perfect square before 28 is 25, of course, which is 5 squared. That gives you 25. And then you have 6 squared gives you 36. Now you see, you can estimate square root of 28 to be something like 5 plus 6 divided by 2. And that is 11 divided by 2. Of course, it's an approximation, don't forget. Just an approximation. That's around 5.5. But the actual square root of 28, if you punch your calculator, it is approximately 5.292. 5.292. So because of that, next time, if you look at the fact that 28 is closer to 25 than 36, so if you want to, instead of instead of making it 5.5, you can actually bring it lower. So we can try that out for the next one. But I mean, 5.5 is still just a bit close to 5.292. Okay, so that goes. So this is our estimation. Okay, so this is the actual result. Now let's go to the next one where we have square root of 150. Now, if you look at 150, uh, square root of 12 here, 12 squared is 144. So automatically, we know the next is 13. So 13 squared is 169. And then if you look at 150, 150 is just 6 away from 144, but it is 19 away from 169. So you can borrow wisdom from square root of 28 to make a better decision in this case. So here you can now say that square root of 150, normally square root of 150, if we're doing the actual averaging thing, that'll be like 12 plus 13 divided by 2. That'll be 25 divided by 2, which is 12.5. But because 150 is closer to 144 than it is to 169, then instead of just saying 12.5, you want to make it as small as possible so that it can be something like, say, instead of 12.5, you can say 12.3. That's my guess, which is, we are just estimating. It's not the actual result. So, but if you punch your calculator, so what do you get? If you punch your calculator, you have something like the square root of 150 is actually 12.247. So you can see now the answer is closer because I took into consideration that 150 is closer to 144. So 12.247 is still a bit close to 12.3 than if I had written 12.5. So let's go for the next one, square root of 55. Now, looking at 55, the closer perfect square to 55 is 49, I believe. That's 7 squared. So you have 7 squared, that's 49. And then you have 8 squared, that is 64. Okay. And then if you look at 55, 55 is just 6 away from 49, whereas it is 9 away from 64. So it's not exactly in between, but it's not as far away as the previous situation we considered. So my estimation for square root of 55, and instead of 7.5, Okay, again, 49 is just 6 away from 55, but 64 is 9 away. So it should be something very close to 7.5. So I can estimate it to be like 7 point, say, maybe 7.4. Let me just say 7.4. But the actual thing, if you punch your calculator, oh, interesting. The actual thing, if you punch your calculator, is this. Square root of 55 is 7.416. So you can see by taking the gap into consideration, you can make a more accurate guess. So the actual square root is 7.416. All right. So normally I should do the last one, right? But I give you that to try. What is the square root of 200? So of course you look at the average part, but also look at how far it is from the closest perfect squares. All right. So on this note, um, we have come to the end of this. All right. So don't forget to subscribe to the channel. See you later. Bye.